Welcome to today's webinar brought to you by Delphix and Manta. I'm Stephen Fegg, Director of Database Trends and Applications and Unisphere Research. I will be your host for today's broadcast. Our presentation today is titled, Bridging the Gap Between Data Management and DevOps. Before we begin, I want to explain how you can be a part of this broadcast. There will be a question and answer session. If you have a question during the presentation, just type it into the question box provided and click on the submit button. We'll try to get to as many questions as possible, but if your question has not been selected during the show, you will receive an email response. Plus, if you would like a copy of the presentation, you can download a PDF from the Handouts tab on the console once the event is archived. And just for participating in today's event, you could win a $100 Amazon gift card. Now, to introduce our speakers for today, we have Lenore Adam, Director of Product Marketing at Delphix, and Ernie Ostic, Senior Vice President of Products at Manta. Now I'm going to pass the event over to Lenore.
All right, thank you. Hi, everyone. Thanks for joining today. I'm Lenore Adam. I'm on the product marketing team here at Delphix. To stay true to the theme of today's roundtable, my goal here today is to help answer the question, how can data keep pace with DevOps requirements of speed and flexibility? So we'll talk about unclogging your data pipelines, creating faster, higher quality feedback loops for app dev, establishing a default deny defense for sensitive data in non-prod, and wrangling data for complex integration testing. All right, so let's get started. Enterprises face constant pressure to rapidly release new products and capabilities to meet intense market demands, and DevOps teams are rising to the challenge by delivering innovation faster than ever thought possible. With the incredible agility and CI/CD pipelines, they have established automated, repeatable software delivery processes to streamline work in progress and improve productivity. But while DevOps workflows have been optimized, the data pipeline that feeds the release train is not. Data places tremendous drag on release velocity, but is surprisingly overlooked when evaluating the speed of the value stream. Whether public or private, cloud programmability gives DevOps teams tremendous flexibility in application development. Automated code and infrastructure helps DevOps teams accelerate delivery, but an automated pipeline requires infrastructure, code, and data. The speed of the software delivery lifecycle depends on how quickly you can provision these three components. So what specifically do we mean by automating data? We're talking about automating legacy manual processes for provisioning, refreshing, and securing test data for the entire software delivery lifecycle. In a continuous delivery model, there's a tremendous demand for test beds. When we used to just have yearly or even quarterly cycle times, there wasn't a huge demand for test beds. To achieve faster development cycles, whether in 2-week sprints or in continuous integration models, you're going to be breaking code more often and in rapid succession, leading to an almost continuous testing cadence, which in turn increases demand for test beds. And the increasing adoption of services architectures increases that need even further. With an automated cloud-based infrastructure, test beds can be spun up and down to match the pace of code changes being introduced. One of our customers told us that the average life of an ephemeral test environment for them was just 21 minutes. So there's tremendous demands for the data pipeline to keep pace with speed and volume of test environment creation. Data operations have to be automated. Let's drill down a little further and look at what this means in a typical CI/CD pipeline. Waiting even a few minutes for test data to be delivered breaks their efficiency, but the reality is that data wait states can be weeks or even months because of legacy ticketing systems and manual coordination to provision test data. And when destructive testing requires a data restore, the request is run through the same manual process, which adds even more delays. What we do at Delphix is automate complex data operations so data can be joined to the automated release train. At the core of the Delphix technology is a database virtualization engine that ingests production data to create virtual databases that are easy to replicate and provision. Once we have these nimble virtual databases, we take those data operations and automate them with just a few lines of code. So instead of taking weeks, terabytes of data can be delivered in minutes. For example, restoring a virtual database after destructive testing is a simple rewind executed without the need for DBA resources or IT tickets. When DevOps teams codify data, they begin to think about their pipelines in completely different ways, such as testing multiple code changes across identical test beds, turning traditional serial testing into highly efficient parallel testing. Here are the different data operations available to Dev and test teams. Data provisioning, bookmarking, rewinds after destructive testing, and refreshes with the production database are all automated. Developers have independent read-write control of the virtual databases so they can time travel and version control data like code and eliminate long-standing data bottlenecks. I've included this quote because I think it helps explain the scope and scale of a typical DevOps pipeline and why automated data operations are imperative. This customer deploys 1,700 test instances a day, and automating the data tier helps them iterate faster and expand their test coverage. Leveraging virtual databases and automating data operations greatly improves the efficiencies of DevOps pipelines. We need to also consider the quality of the data that is being delivered. A key component of a DevOps practice is leveraging smaller batch sizes to accelerate the feedback loop for developers. These optimizations are often reflected in two core DevOps metrics: lead time, which is the elapsed time for code changes from check-in to release, and deployment frequency, which measures how often you can deploy code. In the DevOps realm, we often talk about shift-left testing, meaning testing early and often to facilitate these rapid feedback loops. An important element, though, is to leverage test environments that are as close to production as possible to ensure comprehensive test coverage, and that includes test data, which should also reflect the full production instance. Maintaining a continuous flow of production quality data to test environments is essential at every stage, especially when databases have a high rate of change. This chart reflects the findings of a recent IDC study about the value of delivering high-fidelity data. What it's showing is there's a significant amount of hidden wait states, waste, and rework caused by the right data not being available to developers and testers when they need it. Without rapid delivery of quality test data, teams use stale data or resort to subsets just to keep the release train moving. They risk missing edge cases or complex data scenarios, sending issues further down the pipeline where it's harder to triage and more expensive to fix. By introducing production quality data earlier in the test cycle, DevOps teams find data-related defects sooner, meaning bugs are found 1, 2, and sometimes 3 stages earlier when they're 1/10 or even 1/100th the cost to fix. Shifting left with production quality data can help balance the software test risk equation by both improving software quality and increasing developer productivity. Using subsets of data or even just using outdated data results in both false positives and false negatives in testing, which either slows the release train or means errors continue down the pipeline and out into production. IDC research on our customers showed that shifting left with production quality data decreases errors leaking into production by up to 70%. And these are the kind of stats we see when our customers are able to treat data like code. By significantly reducing data provisioning time, they're able to improve the speed of dev cycles and keep pace with automated workflows, like this customer who now executes over 1 million CI/CD runs per month using fresh quality data. Another area where data needs to keep pace with DevOps flexibility and speed is in securing sensitive data that resides in all of these non-production environments. They present an enormous attack surface for bad actors inside the organization or from hackers infiltrating the IT system. The unfortunate reality is that this sensitive information in non-prod environments goes largely unprotected. This research shows that 56% of enterprise customers don't anonymize personally identifiable information in test environments. Unfortunately, organizations often find that the process of anonymizing or masking sensitive data to be at odds with the speed of DevOps workflows. This level of security in non-prod environments is viewed as a barrier to innovation. We also see many companies attempt to use a homegrown masking solution where they manually go through hundreds, if not thousands of tables to discover sensitive data. We describe this as a cracked dam, meaning these poorly executed processes leave organizations at high risk of inference attacks and sensitive data leakage. Adding to the challenge is the fact that data regulations are continually evolving. Countries and states all over the world are issuing privacy regulations that broadly apply to businesses, such as GDPR and CCPA. So while you've got this pressure from regulations to secure data, there's also a growing need for more data-ready environments internally. And it's not just for application development, but for requirements such as business analytics, machine learning models, and cloud adoption projects. Outsourcing development or use of third parties for additional data processing expands the risk even further. Without a comprehensive masking strategy, you're basically distributing more and more sensitive data and increasing your compliance risk. Manual processes aren't a sustainable solution for all of the sensitive data in lower-level environments. There's a crucial need for compliance automation, so security is no longer a hindrance to innovation. Delphix automatically discovers sensitive data by searching both column names and the data itself. Customers leverage pre-configured regulation and application-specific profiling and masking algorithms to eliminate manual efforts and replace those homegrown scripts that are slow and fraught with error. Masking irreversibly changes the data to make it useless for a hacker. The data is still useful for app dev and other use cases, however, as the process replaces sensitive data with realistic but fictitious data. In addition, deterministic algorithms replace data consistently, and metadata is tracked to maintain referential integrity. So we can add discovery and masking of sensitive data to our list of automated data operations. The last topic here relates to making data available for app dev environments, given the complex nature of an enterprise data ecosystem. DevOps teams are continually driving innovation across a highly interconnected web of applications and services that requires sophisticated systems integration testing before deploying into production. The data sources that make up the enterprise landscape are continually growing in complexity. Applications and the underlying databases are housed in many locations on-prem and across clouds. There's also different infrastructure models to consider when dealing with data in the cloud. Access to data is quite different depending on whether the data resides in IaaS, PaaS databases, or SaaS applications. There's also increasing diversity of data sources as data architects choose more fit-for-purpose databases over a monolithic data source. Prod data and non-prod environments are not necessarily in the same location, and delivering data for integrated test environments can really be challenging. I wanted to share the results of a recent survey to illustrate the growing diversity of data sources. In this first chart, we see that despite the trend towards cloud adoption, over half of the respondents said that either legacy apps and databases are not supported in the cloud, or they are just too large and complex to migrate. So there will continue to be a mix of on-prem and cloud-based applications and databases to deal with. And in this chart, we see the specific trends for those data sources that have been moved to the cloud, where there's increasing use of PaaS databases, open source technologies, as well as fit-for-purpose data sources. All this adds to the complexity in creating quality integration testing environments for complex enterprise application stacks. Testing transactions and functionality that traverse these interconnected systems requires coordination and synchronization of these diverse set of data environments. And integration testing is often one of the hardest problems to solve for DevOps teams developing these complex apps and business workflows. To solve these challenges, we're able to provision synchronized data from multiple heterogeneous sources wherever they're located. The virtual databases we create are readily transported when production and non-production environments are not co-located. These virtual data sources can be synced to the same point in time, so dev and test teams can time travel them as a single unit. This coordination is also reflected in data masking rules, where referential integrity is preserved across these diverse data sets so that comprehensive tests can be thoroughly validated while remaining secure. These advanced capabilities, Here we go, sorry about that. These advanced capabilities are why we're able to support enterprises around the world to automate data operations and compliance. Morgan Stanley leverages Delphix data for DevOps to increase development productivity across their 160 applications. Their data grows by over 1 petabyte every month, and yet their DevOps teams have ready access to up-to-date data in minutes, which significantly increases the speed of development and delivery of application code. This is my last slide. So the goal today was to explain how data can keep pace with DevOps requirements of speed and flexibility. The summary answer then is that data automation for DevOps is about both increasing speed of delivery and improving the quality of data available throughout the CI/CD pipeline, resulting in exponential gains in efficiency without sacrificing security. And feel free to drop in any questions in the Q&A. I think we'll wait to the end before we address them, but thank you for your time. And now I will pass the baton to our next speaker.
Thank you very much, Lenore. At this point in time, I'd like to introduce our next speaker today, Ernie Ostic, Senior Vice President of Products at Manta.
Thank you, Stephen. Appreciate it. And welcome everyone spending this time with us today. One of the things I'm going to be talking about is this new term that, it's not so new, but the last few years we've been hearing a lot more about DataOps. And DataOps owes its origins to the methodologies that are part of DevOps, and also, combines it with the disciplines of data management, and especially the need for robust and reliable data pipelines. So what we're going to look at in this next few moments is the discussion around data lineage and how important data lineage is for you to be successful in your implementations of DataOps to support your pipelines. So for a quick agenda, we're first going to talk about what do we mean by data lineage. There are a lot of different terms that are out there and definitions of data lineage. It's fairly well established now, but I want to be sure that all of us here in this particular call have a consistent definition. We'll then look specifically at some of the DataOps use cases. Now, those aren't the only use cases for lineage, so we'll mention some others, but then we'll dive in a little bit deeper into DataOps and lineage. And finally, I'll conclude with a short overview of Manta, who we are, and what we provide specifically for this important area. So what is data lineage? It's the ability for an organization to track how data flows throughout. Particularly, this is important in the lands of analytics and data analysis, but ultimately points to all the places where data is flowing throughout the organization. Where does it come from? Where does it go to? What happens to it along the way? What are those sources where the data is, first brought into your organization? Maybe it comes from a subsidiary. Maybe it comes from an application where people are actually entering the data by hand. Maybe it comes from online transactions, point of sales, etc. But eventually it gets sifted down because people have to use it. It goes into data warehouses, it goes into data marts, it goes into analytics systems, perhaps that you have in the cloud, perhaps elsewhere. Right? It gets moved around from place to place, and along the way, hit by ETL tools, by stored procedures, by even manual extractions, or using wonderful tools like Lenore just described to us. And as it moves through that process, there are times we need to know what happened to it, how was it transformed, what are the individual expressions that might be used to actually convert data or calculate certain things. And ultimately, when it's at some other end, for purposes of better understanding of the data or for solving problems when data pipelines sometimes inevitably break, or better yet, preventing those pipelines from breaking by looking downstream, doing impact analysis, are key reasons where lineage is important. But that's what we mean by lineage. Come from, where does it go to, which way you're looking, upstream or downstream, and what happens to it. But sometimes it's hard to achieve. There's many different reasons. A really big one is business versus technical view. The technicians, we want to see exactly what the gory details are. I want to see the syntax from an SQL statement, or I want to dive into the details of a particular ETL tool that I'm using, because I might not be the developer. I want to avoid the need to have to make phone calls and emails to try and track something down in some source code. I want that to be surfaced in a place where I can see it. The business view, though, may not need that level of detail. They might want to only know that something comes from the commercial loan system and leads to risk reporting. And maybe they might drill down a little bit further, but they're never needing to go down to the individual transformation level. And so that causes conflict, being able to deliver that information in a way that anyone can consume it. How often the data changes is one thing, but in this case, we're talking about change of code. How often are we constantly updating and changing the transformations of the way the data is moved? How often do you return new code to your production systems and manage it in such a way that you can track one versus the other? And for lineage, depending upon who it is that's asking, we often need the ability to go back in time and actually see how did the data flow, what was the calculation at the end of Q1 versus today. And data lineage, when tracked in a historical fashion, is able to deliver that. Companies evolve. Acquisitions occur. People are promoted. They move on to new roles. That means that there's always different technologies, different multiple databases, multiple philosophies, data warehouses turned into data lakes, or one is supplying the other depending upon how your organization has adopted those methodologies. There are programming languages where you still might have COBOL, but you also are doing work in Java. And you might be doing work in different ETL tools because maybe you did an acquisition where brand ETL tool A is being used by one company, purchased by another, who adopted ETL brand company B. But the code doesn't go away immediately, right? It still is part of the pipeline. And being able to provide visibility and traceability along that whole pipeline becomes important. But it's hard because of the fact that there's so many different technologies and different people. And not everyone has been around the water cooler so to speak, and understands the tribal knowledge of which databases are most important or most valuable, or which spreadsheets have proven to be the most useful. And so Lineage can help answer those questions and provide us with that visibility that's so desperately needed. When we look at data lineage use cases, I've mentioned some of them already, but data governance and regulatory compliance, application migrations, especially to the cloud, data quality monitoring and evaluation are all key things that are whose benefits are gained by data lineage tracking and management and reporting. But let's talk specifically about DataOps for pipeline visibility and reliability and how Lineage helps there. So first off, it's accelerating debugging with immediately available end-to-end lineage reporting. Something happens. It's inevitable. Sunday morning, a report's not particularly available. Why? Which part blew up? Was it a loading of an ETL tool into some lookup table and it didn't get the rows that it was supposed to because there was a bad or null date in there, and so it loaded 0 rows, and now everything else fails down the line? Being able to have immediate lineage to help track that down is critical for the folks that have to perform that activity. It's great to be able to use Lineage to detect changes. A new stored procedure includes new columns. Should we put this stored procedure into production? Is it going to be safe? Which reports does it impact downstream? Is there a chance that it might break something downstream and therefore that report's not going to get delivered where it's supposed to? So this can be done when the stored procedure is first put into test, and it can be checked to make sure the lineage is reliable. Impact analysis is something that can and should be done as part of all your maintenance activities. Checking lineage and ensuring that that stored procedure is not going to break things should be a required checklist and checkbox. And having lineage to show what that is can be attached to that object when it's prepared to be put into production. It's also useful to deliver lineage reports proactively. So that lookup table I mentioned earlier, if it fails and you have good DataOps disciplines in place, you'd know that right away, because there might be a test that was built in that says, check to make sure that there's at least 1,000 codes in our products table. If there aren't 1,000 codes, then there's something went majorly wrong. And so you're going to put out a notification immediately to the people that care. Attached to that, a lineage report, a URL that can illustrate the immediate lineage, so the person who receives that report can immediately check where is that lookup table in the pipeline, which ETL program, which part of the entire data flow is responsible for this. And finally, lineage solutions offer instant lineage. Be able to check that SQL statement before it's ever put into place. Validate it's the right one. Or when you're building that report, ensure that the select statement that you're constructing is exactly the one that you want it to be, and see it visually, especially if it has lots of complex joins and where clauses and you aren't exactly sure what the impact is. This can help streamline that overall development process. Here at Manta, we determine lineage by going through your code. We crunch custom SQL, ETL from all the popular ETL tools, all the popular business intelligence tools, the databases in the cloud as well as on premises and their stored procedures. We look at code, we review COBOL, and we review Java code to see exactly how these flows are interacting with their frameworks and the files that are their sources and targets as they move around. And while we're parsing through that code, we don't look at data, we look specifically at code. We document the lineage. How does this column flow into this other column, and how was it transformed in that syntax? And we visualize that lineage in an interactive map that's fully color-coded and down to the detail level with lots of filtering. Or we can push it, in addition, to a third-party governance solution where you might look at it at the higher business level, and therefore it becomes a hybrid to support the business users as well as heavily technical users. Thank you. Any questions? Move on to our
Thank
next
you very
piece.
much.
I'll give it back to you.
Oh, thank you very much, Ernie. Yep, we're going to dive into attendee questions. The first question is for Lenore. Lenore, how big of a storage footprint is required for virtual copies? Are they the same size as the production database?
Yeah, good question. So virtual databases require much less physical storage than a physical database. You're usually looking about a tenth the size of a physical database. That's because we're taking unchanged data blocks and keep making them common to all virtual databases that are distributed, no matter how many there are. So without requiring additional physical storage in that case, so no matter how many times they're replicated, you don't need additional storage. And then we only need additional storage for data that has changed for each virtual database. So we're tracking that change data, and that's the only element that requires additional storage. So that's how we get the, in the end, about a tenth the size of the storage needed.
Understood. Thanks. Ernie, our next question is for you. What is a good starting point for implementing Lineage? How do you get going?
Excellent question. And, you know, there's so many different use cases, but to really get familiar with Lineage, it helps to look at where are your biggest pains. You know, where have you been having issues in the, you know, DataOps pipeline case, or, you know, which of your users have been the most frustrated with being unable to get the details and results of the spreadsheets and reports that they're looking at. And generally, it helps to start with one component, right? So maybe that's, you know, the stored procedures and routines and scripts that you have in your primary database that's feeding those reports. It helps to take a segment, take one schema, take the, you know, 250 views and the stored procedures that are in there and scan them and exactly see what that lineage looks like. So you can get an idea of what it can provide without kind of trying to take on the entire enterprise. The goal, of course, is to have end-to-end lineage. But if you focus on one particular resource first and appreciate not only how the lineage works, but also who your audiences are that most seriously need it, that is a really good way to take a bite of it.
Got it. Thanks, Ernie. Lenore, our next question is for you. Are you able to use virtual databases to migrate data from on-prem to cloud?
Yes, actually, virtual databases are really flexible in that situation. So just to give you an example, we had a customer who needed to migrate their 50 terabyte production database, and they had a very small window to do it in. So they were able to use their virtual databases to practice ahead of time that migration. They could practice it over and over again so that before the final migration, they could ensure that all their processes and configurations and network settings were all efficient and predictable. So once they did that final migration and using a virtual database, once that was complete, they were able to execute then a virtual to physical conversion to reinstate the production instance in the cloud. So it really helps kind of before, during, and after migration to have that flexible virtual database.
Thanks for clarifying. Okay, Ernie, we're going back to you. Question is, can lineage information be saved or archived for review at a later date?
Another excellent question. The way that we perform lineage is in what we like to call time slices. So it really depends on the organization, but a typical happy medium might be that someone is doing analysis for lineage once a week, right after they've returned all those stored procedures and code into production. And so perhaps on this weekly basis, we're seeing the changes implemented. And then that means there's a time slice of what did lineage actually look like on July 31st? What did lineage look like on June 30th or at the end of Q1? And so because those time slices are taken, it means we can go back to any point in time and see exactly what the picture was. Right, so if someone comes into your office with their hair on fire and says, oh my gosh, I need to know exactly how we got the data and where we came up with this number at the end of March, right? Then we can just simply go back and look at the lineage for March. But even more powerful, perhaps, is to actually say, let me compare the lineage of March to the lineage for the end of August. And let's actually see where the differences are and to view them graphically.
Understood. Thanks, Ernie. Okay, Lenore, we're going back to you. The question is, do you replicate the data to the cloud and then mask it? Can you clarify where in the process data is masked?
Sure. So let's just use the example that you've got production on-prem, but your app dev in the cloud, either ongoing app dev in the cloud or if it's part of a migration, doesn't matter. We would mask the data on-prem before it ever leaves the production network, so it can be securely transferred and used in cloud-based dev environments or any other non-prod environment. We have customers, for example, that are masking data on-prem and then sending it to, let's say, Google Cloud for analytics purposes. So then they're able to take advantage of that analytics platform, but do it in a secure manner. So again, we're just masking on-prem before we ever send it.
Got it. Thanks, Lenore. Ernie, back to you. The question is, how would I run an impact analysis with Manta?
Another excellent question. So impact analysis generally is the idea of doing lineage looking in a downstream direction. Because what we're trying to do is determine the impact of some change you might make to a piece of code that's upstream, right? Changing a view, changing a stored procedure, and being concerned about what it might impact down the line. And so the way Manta operates is typically a scan is performed, as we talked about just earlier. And, it might take some time to go through hundreds of stored procedures and hundreds of views, so that whole process takes place. But then if I'm making changes to some particular table or view or stored procedure, I know what that stored procedure is. I'm about to return it. And so I'm going to go into the repository where I'll have this whole long list of all the views, tables, stored procedures, etc. I'm going to select a particular one and say, show me lineage. Now, specifically for impact analysis, I could actually choose, which will filter it, make it run faster. I can say, show me downstream lineage or impact analysis. And what that's going to do is show me everything that particular set of elements flows through. So maybe, it's name, address, phone number, to make a simple example, but that actually flows from that stored procedure into other tables that are then used in views that are picked up by ETL tools that eventually lead to a completely separate database, which then leads to a bunch of reports, right? And, understanding where those reports are, which group they're in, if they're in risk, and I know what which part of the bank that's going to be using those, I can very quickly determine not only whether it's impacting something that potentially could get broken, but also who is it impacting, right? If I know that particular group is one that's going to be especially concerned, if their reports are broken. So that's typically how you would do an impact analysis going downstream. Understood.
This is a question I think both of you can weigh in on. Lenore, why don't we start with you? Has the growing adoption of cloud platforms made bridging the gap between data management and DevOps easier or more difficult?
Well, there's pros and cons. Actually, so that's a really good question. We see,
You know what, Lenore? We're having a little bit of a difficult time hearing you.
Sorry, it's me. On speaker, sorry. So we've got, as we were looking at some of the survey questions that we had, we see that some data is going to remain on-prem. That's just kind of the nature of the beast. But then once you move into the cloud, you're dealing with a greater diversity. You've got data that's sitting in IaaS. You've got data sitting in PaaS databases. You've got data in SaaS applications, and they all have different kind of access models, really. You can't necessarily access data like you used to be able to on-prem if you've got data in a PaaS database or in a SaaS application. You don't necessarily have unfettered access to that data anymore, which can be good and could be difficult because it really changes your processes. And then you're just moving data around a lot more to get it to, say, an analytics tool or to an app dev environment in a different cloud. And so it's really on the move quite a bit, and so therefore it has to be secured. And a lot of people will say that data is moving to the cloud faster than organizations' ability to secure it. So you have to be doubling down on security strategies in the face of increasing cyber threats, and whether it's ransomware or extortionware, that just has increased. It's irrelevant because it's in the cloud, but it's just a growing threat no matter where your data is. So you've got lots of flexibility, but you have got some sort of procedural things to consider depending on where your data is located in the cloud, as well as really increasing your security and revamping security environments and strategies.
Understood. Ernie, what are your thoughts on that question? Is the adoption of cloud platforms making bridging the gap between these two areas more difficult or easier?
I think basically it's just expanded the kinds of challenges people have, especially since I'm talking about the lineage area, but the challenges they have in trying to keep track of where the data is coming from and when it leads to cloud locations, regardless of what kind of cloud that someone is working on, whether it's moving into one of the brand new, very popular branded cloud databases, or a legacy one that's now expanding into the cloud area. It's got to be loaded. Does it get loaded through some staging area like Amazon S3? Can we track it? Is the syntax understood so it can be picked up by lineage tools such as Manta, which we do? Are there new bleeding edge tools that have to be kept track of as far as coming up with ETL and reporting? And sure enough, there's many of those that go on. But it's also one of understanding what you have if you're going to migrate it, and being able to perform analysis of your existing systems to find out, do I need to even migrate everything? Am I using all these views anymore? We've had significant numbers of companies who look at the reports that they have in a legacy system, one that they might have had for 15, 20 plus years, and finding that they only really use 10% of the original reports. But without doing lineage, there's no way to determine which parts of that system are still necessary. And so a lot of places will often have to do a very expensive lift and shift of all their resources to the cloud, when maybe, in fact, they only needed a subset of those views and stored procedures and tables.
Understood. We actually had a lineage-specific question just come in. How does lineage work if the RDBMS itself is connecting various sources?
Oh, very good point. So a lot of it depends upon the particular tooling and database or language or facility that you're using. But what typically will happen, particularly if we're examining a stored procedure or let's take an ETL tool, those ETL tools will often identify themselves as to whether they are reading from Oracle, or they're reading from DB2, or they're reading from SQL Server. And so consequently, the scanner, right, as it goes through the ETL tool and it sees that, oh, this is actually complex SQL, but it's actually going to Oracle. Let's invoke the Oracle technology scanner. So because there might be some specific dialect orientations within that SQL that only work in Oracle. So we need to call that particular scanner. However, that ETL tool might be taking that Oracle information and inserting it into another database, maybe pushing it up into the cloud or putting it into Microsoft SQL Server, for example. So it's important then that the ETL technology passes off the scanning now to, in that case, Microsoft SQL Server, so all the interesting insert syntax dialects that may not be standard ANSI SQL are also picked up. And so that you get that cross between them. That's typically how that's done.
Understood. Okay, well, we've gone through our attendee questions. I have one more question. I'd like to give each of you some time to, address final remarks around. If there's one thing you would really like our attendees today to walk away keeping in mind, what would that be? And why don't we start with you, Lenore?
I think it's that data is we all know data is growing exponentially. It's getting increasingly complicated. Even though we've got the flexibility of the cloud, there's growing diversity. But there are tools to kind of get your hands around it all. There's automation tools like we've described ourselves, as well as what Ernie has been describing. So there's a way to manage it all, but it's going to take some changes to existing processes. It's time to reevaluate those processes. It's sort of the to kind of remove that boat anchor that it was a boat anchor in legacy environments. And so as we move to to the cloud, it's increasing different infrastructures and increasing diversity of data itself. It's time to start reviewing those processes and taking advantage of automation.
Understood. And Ernie, your final thoughts?
I think the big takeaway is for everyone to recognize that every organization is doing lineage. And they do it by screaming down the hallway. They do it with phone calls. They do it with email. They do it with Slack messages. It gets tracked between different people, different technologies, and documentation that's weak. And it takes an enormous effort to try and come up with consistent and accurate lineage quickly to answer questions or prevent problems from occurring. And without an automated solution to really dive through legacy code, current code, new databases, old databases, etc., and provide that map, through your existing systems, most people give up, and they don't have any lineage at all. And so they're not able to answer their regulators. They're not able to prevent problems in their pipelines, or they're not able to easily solve those problems. And I think that's really the thing I would want to leave people with, to really look at how you're doing lineage and what do you need to do to ensure its validity.
Understood. I would like to give a big thanks to our speakers today for sharing their expertise and insights. Once again, Lenore Adam, Director of Product Marketing at Delphix, and Ernie Ostic, Senior Vice President of Products at Manta. If you would like to review this presentation or send it to a colleague, you can use the same exact URL that you used for today's live event. It will be archived, and you will receive an email once the archive is posted. Plus, if you would like a copy of the presentation, you can download a PDF from the Handouts tab on the console once the event is archived. And again, just for participating in today's event, you could win this $100 Amazon gift card. The winner will be announced on August 31st. We will notify you by email if you are the lucky viewer. Thank you, everyone, for joining us today, and we hope to see you again soon.